Hey everyone, it's Chris here. So I wanted to share this tool with you that I created for some of my own internal tasks, and I couldn't find something that does the job properly. And the challenge is working with IFC models and extracting the solid geometry and bringing that into either AutoCAD or the IGES format or step files or whatever it may be for other downstream processes. In my case, I wanted to use Solid FEA to generate a model of a massive pile cap base with a lot of rebar that was modeled in Revit. So I'm going to show you what I did and how you can use this tool. So if you head over to bimworksfea.com, you can then just from the menu there under tools, click on IFC model converter. That's going to download the installer. So it's digitally signed and everything, so it should be all good. Once you run it, you'll see the confirmation screen. Just click yes, accept the agreement. You can read through it first if you want. Choose to create a desktop shortcut if you like, and install it. It's not a massive application, so it should go fairly quick. And once it's done, you can run this app. And when it starts up, it'll ask you to select a IFC file. You can also from the list select IGES or step files to import, but generally I developed this to extract 3D model content from IFC files. So once you've done that, you can go ahead and open up your IFC model, and this is the example model that I've been talking about. And it'll just take a couple of seconds to read the data, extract all of the geometry, and convert that into BREP watertight solid. So we can see that here represented in the view. Now, this is what it looks like. I exported my Revit model, and I'm going to show you what that looks like over here. I've exported this to IFC. I used different formats for testing, but I set my detail level to low just because that helps me when I create meshes downstream. So if I look at my IFC setup here, we go to level of detail, mine is set to low. You can of course set that to a higher level if you choose a different setup here. For me, that's what I needed, a low level accuracy, especially on the rebar, which is good enough for me. So anyway, so that's what I've done there. Now, just to show you, I brought this into Navisworks, and obviously, as you might know, it does a great job of representing the rebar content. Well, actually not that great. You can see there's some parts missing. But if I open up some of the other models I've created here, like the first one, I think, then it should represent a little bit better. Anyway, the point is, once you've got it in Navisworks, unless you have the paid plugins to export the geometry, there isn't much you can do with it apart from sending it to FBX. And that doesn't really help me. I want to be able to work with the actual elements and do stuff with it. Now, you might say, why not just export this directly to DWG or the SAT formats or the other formats that is already supported in Revit? The problem is, even if you set this to ACI as solids in the export setup, when you export it to DWG, especially with the rebar, you end up with elements that are split for some odd reason. So the base comes through quite nicely. Okay, well, it's a block reference. Let's explode that, and let's see if we end up with a 3D solid. Yes, we do. The problem is the rebar. You'll see in this case, my bar is split into different segments. So it's split it up for some reason, which is quite annoying. And I end up with block references again, and then finally it's a body element. Now, I've played around with some of the settings in Revit, and what I also tested was to send it out as different formats. So I tried STL and ACI SAT. Same problem. The STL kind of works. The problem is you cannot import STL files into AutoCAD. You can export STL files from AutoCAD, but you cannot import it, which is quite annoying. So the whole point of this tool is we can export to many downstream 3D formats. So once you've got the model loaded, click on the blue button here, Export Solid Model. From here, you can choose to export to IGES, DWG directly, step files, or STL. And I'll show you what it does with the export here. And I'll just call this one example 123, so you can see it in action. We'll save it out, and once it's done, it's going to open up. It's currently busy, but once it's done, it'll open up the File Explorer and highlight and select the file that has been exported. And looks like it's done. It's opened it on my other screen, but here it is. That's the file. It's just been exported right now. And if we go back to AutoCAD and open this up, we should be able to see what it looks like. So there's the example 123, 16 megabytes, which is not bad because I just want to show you some of the other formats that I've tried here. These are all the ones that I've tried to export. You can see I've got step file here with 1 kilobyte, so that obviously didn't work. This is the IFCs. We've got an IGS file here of 200 megabytes. I've got another IGS of 100, another IGS of 226. We've got a DXF here of 400 megabytes, an STL of 481. So the 16 megabytes that we get from this exporter is not bad at all. So opening it up opens up quite quickly. And if we look at the model geometry here, we can see that everything here are solid entities exported and connected. So they're all welded together. So if we look at our quick select here in AutoCAD, we can see we only deal with 3D solid watertight entities. And that's, at least for me, what I needed to be able to do with IFC files. Now, in this case, I did have access to the native Revit model, but even then it was a challenge getting the 3D geometry into my downstream processes. But in many cases, I end up with IFC files, and I wish I could extract the geometry so that I can work with it downstream and make some changes and stuff. In this case, this tool does that for you. I hope that can help you too. So again, just head over to the bimworksfea.com. Under tools, you can just click on IFC model converter, and there you go. All right, have a great day. Cheers, bye.